Part 1. What is fluid pressure? As in the name, fluid pressure defines the forces that are applied to fluids and the varying fluid properties. Pressure applied at any point of a fluid in a cavity will spread across the whole containment of fluid equally, resulting in pressure equilibrium. Additionally, fluids themselves can exert two types of pressure, static and dynamic pressure, static pressure being applied when the fluid is at rest, and dynamic pressure being applied when the fluid is in motion. This is a diagram of fluid pressure. It shows two containers filled with gas, which is being compressed with a cylindrical material at bipolar pressures. The first container is under a low amount of pressure, giving the gas particles more space to move around it, while the second container is under higher pressure, causing the gas particles to have limited space for motion.
Part 2. How does fluid pressure change in a fluid? Insights. A fluid's pressure can be altered due to a multitude of causes such as depth, density, flow rate, temperature, or compression. According to Vedantu, these factors are all directly proportional to pressure and are positively correlated, meaning that an increase in any of these factors will result in an increase of fluid pressure. When fluid pressure increases, there is a slight reduction in the distance between the packed molecules of a fluid and vice versa. This proportionality is represented by this chart that displays the positive correlation between density and fluid pressure in a line which is akin to a logarithmic function. Now, let's better understand some of the factors that can influence the pressure of a medium. Gravity. Gravity is a less known but certainly notable factor which impacts fluid pressure. A lower gravity would result in a decreased atmospheric pressure and weaker gravitational pull. Thus, the downward force on a fluid would be reduced, consequently exerting less pressure at any given depth. For instance, if we were to compare fluid pressure on Earth to fluid pressure on Mars, there would be significantly less pressure on Mars due to its lower gravity of 3.71 meters per second squared. Density. Compared to less dense fluids, denser fluids exert more pressure at the same depth due to the compactness of mass in the same volume, causing greater pressure to be exerted on any submerged objects. An example is that saltwater and freshwater cannot mix easily because saltwater is denser due to its higher salinity, which creates a natural distinction called a halocline where the two layers resist mixing, also caused by a difference in fluid pressures. Oh my gosh, is it really what I think it is? Exoplanets? I must investigate. Damn, I'm feeling so exhausted. I need to take a dip. I hope my sensitive alien skin doesn't get damaged. Whee! Whoa, there's way more pressure from this water than water back on Flopmonk. I cannot handle this. The gravity of Earth is 9.80 meters per second squared, which causes water and other fluids to undergo gravity and exert pressure differently in comparison to other planets such as Flopmonk. That was horrifying. I need to get out of this place. I should check that other orange planet I saw earlier. Wow, this place is pretty cool, and I feel way lighter here. Oh, there's some water? Might as well go for a swim. Wow, there's not as much pressure from this water than back on that other planet. This is great. On the other hand, the gravity of Mars is 3.71 meters per second squared, which is far weaker in comparison to Earth's gravity. This results in less pressure being exerted by fluids as they experience a lower gravity. Well, I should return to Flopmonk and tell the other Flopmonkians about these planets. Whee! Part 3.1. Factors influencing fluid pressure, Part 1. Depth and fluid flow. Impact of depth on fluid pressure. As mentioned previously, depth and fluid pressure are involved in a positive relationship with each other. At a greater depth, a fluid will exert a much greater pressure on anything submerged below. Known as hydrostatic pressure, this is caused by the weight of fluid above which compresses fluid below, consequently increasing its density and pressure. The Mariana Trench is the deepest known point in the ocean, and some individuals have remarkably reached that area known as Challenger Deep, despite the extreme pressure and weight of water above. According to Luther Costa, the pressure at the bottom of the trench is about 15,750 pounds per square inch, which is immense if you couldn't tell. Impact of fluid flow on fluid pressure. When a fluid increases in speed, its pressure drops because faster moving fluids contain less energy available to exert pressure. Conversely, when fluids slow down, pressure increases because it has more energy to exert on surfaces. A real-life instance of this is utilizing a straw to drink a fluid. When sucking on a straw, a lower pressure environment is created inside as air is reduced, which causes this high pressure outside to push the fluid up. This is an image illustrating the Venturi effect, in which a fluid's velocity increases at narrow sections of a pipe, causing a drop in pressure according to Bernoulli's principle. In simplified terms, a lower speed results in a higher pressure, and a higher speed results in a lower.
Part 3.2. Factors influencing fluid pressure. Other than depth and fluid flow, what other factors affect fluid pressure? Some other factors are temperature and the impact of compression. Temperature and pressure correspond to each other. This means that as the temperature of a fluid increases or decreases, the pressure will do the same. The atmosphere consists of many gases, and atmospheric pressure decreases as the temperature increases. This is due to the atmosphere being a free and stretched out space and the air density found in the atmosphere. In the atmosphere, warm air rises while cold air sinks. Warm air equals lower pressure, while cold air indicates higher pressure. This is a circle graph that has shown the gases and the amounts of it present in the atmosphere. As you can see, nitrogen is found the most in the atmosphere with an outstanding 78%, while carbon dioxide is found the least with a fortunate 0.04%. Oxygen, the next necessary gas for all organisms to survive on Earth, makes up a solid 21% of the atmosphere. Compression impact. In layman's terms, compression is the force that applies pressure on matter that causes it to reduce its volume or size. When the force of compression is applied to a fluid, the resulting pressure will spread out evenly in the volume of the fluid in the container. More specifically, the fluid pressure increases as compression urges the fluid molecules to move to the edges of the container and more faster than usual. This here is an image that displays an extravagant watermelon being crushed under the pressure of a hydraulic press. A hydraulic press is a machine that is used to compress materials for a variety of purposes. Whether they are for entertainment sources on YouTube or are used to forge, mold, and punch in industries, hydraulic presses certainly do their jobs efficiently, which can be seen by the demolished life of the extravagant watermelon.